All right, everybody. This is, I'm going to go through the 6.3 binomial distribution mom practice right here. And just remember that my questions will vary from yours, but that'll be fine. You'll get through it with me. This entire mom practice is all about binomial distributions. So without further ado, let's get going. The first one is determining if it is a binomial distribution, and if not, why not. Mr. Smith's history class has 16 males and 13 females. 10 different students from the class are selected without replacing, and the gender of each one is recorded. um, this one, I don't know if I've covered this in class yet. So this is maybe one of those sneaky versions that might challenge some of you. It's not binomial. You can see all the answers are no, except for the last one. Um, and it's going to be this one. Let's just make sure. Woo-hoo. Um, because it says without replacement. So when you take a student out of this class, let's just say, um, and you don't put them back, like the first time you draw a student, let's see, I've got 16 and 13. I've got 29 students in this class. So the probability of it being male is 16 out of 29 the first time I draw. But then if that male student is not put back into the class, the next time there's only 15 males and there's only 28 students. So my probability is going down. It is not staying the same. So they're not independent because of that reason. Okay. Well, I should submit that, make sure it's green. Bada bing. Number two, a seed is planted. It has a 70% chance of growing into a healthy plant. If 7 seeds are planted, what's the probability that exactly 4 don't grow? Let me show you. If you had to show your work, okay, you would be doing, um, let's see, 7 seeds. So, whoops, that's a little too large. You would be doing 7 seeds. There we go. 7, choose 4. Like, which of the 4 seeds are going to grow? And then the probability of success, it says, is 70%, and 4 of them are going to grow. And then 30% is the chance of failure or not growing. And that would be 3. Because remember, these always match. And then remember that these always add to 7, or 7 in this case. Okay, and that's what you're going to type in to your calculator. This is how you would show your work as well. So on the calculator, 7 math probability C4, and then times 0.7 to the fourth, 4 of them grew, times 0.3 to the third, 3 of them did not grow. Now the mom is, I think, pretty particular this time about the decimals. Well, this one actually doesn't say how to round it, so I'm gonna, when in doubt, you guys, I just put more decimals. Just put them all, see what happens. No, it doesn't like it. What did I do wrong? Oh, I read it wrong. That's why. Mine says exactly 4 don't grow. So I have this backwards. I should have um, 3 that grow and 4 that don't grow. Ooh, sneaky, sneaky. Okay, so that. And I would change my work, of course, to match. So 0972405. There we go. 3. The owner of a small deli is trying to decide whether to discontinue selling magazines. He suspects that only 12.1% of the customers buy a magazine, and he thinks that he might be able to buy be able to use the display space to sell something else more profitable. Before making a final decision, he decides that for one day he will keep track of the number of customers that buy a magazine. Assuming his suspicion of 12% of the customers buying the magazine is correct, what's the probability? Exactly 2 out of 14 customers buy a magazine. So this one, it says this time 2 out of 14 buy. So N is 14, R is 2. So it's 14 choose 2. The probability would be 0.121. And 0.121 is a success. Only 2 people buy. And then 1 minus 0.121, they don't buy. And that would be 12. Because again, 12 and 2 make 14. Okay? And that's what you put into your calculator. Let's use this time just to show you the binomial button. Second distribution, binomial PDF. You might have a better menu than this that kind of says what is n, 14, then the probability of success goes next, and then the number of successes. And there's your answer. Let's round that to, does it say how to round it? I don't know. It's matching. So there we go. Okay. 4. This one is just kind of doing all kinds of binomials. So it tells you n, it tells you p, rounding your answers to 4 decimals. So the first part says p is exactly 5. So I'm going to get my normal distribution button with p because it says exactly. 11 trials, 0.3 probability of success, and exactly 5. So let's just do one box at a time. So 0.1321 if I round it to the 4 decimal places. Now, the next 4 are all greater than or less than. So when you do that, you do the CDF button. And when you enter your numbers, the number you put will be included, and then it will add up that number and all the numbers below it. So if I put a 5 here for the next one, that's what I want. It will take, you know, if I often do this. I'll just write these out 4, 5, 6, dot, 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 all the way to what? 12, 11, and 12. I want to get all of these, okay? I want less than or equal to 5. So in this case, you put a 5 there, like that. And that will include 5 and count down. If you had to show your work on like an FRQ or something, I would start with the 5. I would go 12. Oh, it's not 12, it's 11. Sorry, 11. I would go 11 C5, and then the probability of success is 0.3. You had 5 successes. The probability of failure, I like to just do mental math. It's just 0.7, 0.70. I don't know why I do that. Anyone else kind of catch that? Why do I do 0.70 here? But anyway, I'm going to try to be more consistent here. 0.30. Anyway, if I succeeded 5 times, I didn't succeed 6 times. And then plus 4. So now it's 11C4. 4 people buy a magazine. 0.30 to the 4th. 0.70 to the 7th. Okay. And then you do, let me just shrink this down a little bit. I'm writing so big. Okay. Then you do plus dot dot dot. That's how you would show your work. Okay. This is this. Yep. Yep. That's good enough. That's how you show your work. And of course, the calculator can speed it up for you. There's your answer. And in Schoology, on the mom, let's round how they want me to, 0.9218. Okay. Next one says less than 5. The only difference here, folks, is it does not include 5. So I'm going to go grab this back up and make it a 4. And that's it. Again, if it was an FRQ, you need to show your work. I would do the probability of 4 and followed by the probability of 3, and then I'd be done. Okay. Now, the fourth box, x is greater than 5. This is, there's no button that does this on the TI-84. You could use the applet because the applet can do all of these options that we're looking at. What I like to think about with greater than or equal to 5 is going back to my picture here. Okay, I'm not going to do that. Greater than 5 means that it does not include 5. It would be 6 all the way up through 11, right? 6, 7, 8, 9, 10, 11. So the calculator, there's no button that does that. But there is a button that can do this. So for that, you're going to do the binomial CDF button. Okay. And you're going to do 11.3 again. And then you're going to do 5. Now that adds up the blue box. I don't want the blue box. I want the red box. So I'm going to do, to get the red, let me do this more clearly with notation. The probability of x being greater than 5 will equal the 1 minus the probability of x being less than or equal to 5. And that is the blue box, right? Like this is this. Okay? So I got to do 1 minus that on my TI-84. 1, or if you'd rather, you could just go back up here, get your CDF button, put a 5 here, and 92%. That means this blue box, if you want to be a little more concrete with it, this blue box is 92%, which then pretty clearly, pretty simple math, this would be 8%, just rough numbers. But I got to just get a more precise decimal for the MyOpen math. So 0.078, okay, right? So the probability of x being greater than 5 is 1 minus 0.07822 dot dot dot. Okay. Oh, wait, I did that wrong. 1 minus 0.92177 dot dot dot. That's how you would show your work. And it should be 0.07822. Let's see if it takes that. Booyah. Okay, and then the last one, x is greater than or equal to 5. I'm just kind of dancing all around 5 here, right? Greater than or equal to 5. How can I use the CDF button here? If I want greater than or equal to 5, let me copy this and just start again. Copy, move down, paste. If I want greater than or equal to 5, the box that I'm looking for has shifted over a little bit. Now I want including 5 and up, okay? The calculator can't do that. The calculator can do this blue box, right? So this is binomial CDF of 11.34. Remember, the top number gets included. And well, let's find that. 11.34 0.34. So again, I have just found this blue box is, if I round that, that's about 79%. So this would be about 21% because they have to add up to 100. Notation based, the probability of x being greater than or equal to 5. Maybe I should keep it color coded for you. That's the red. The probability of the red is 1 minus the probability of the blue, and the blue is the probability of x being less than or equal to 4. Okay? Which this will be 1 minus 0.789695 dot 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 1 minus second answer. Boop. There I go, 21%. And again, you're going to have different numbers, and your greater than and less than signs might be totally different. Which is one reason I really like these mom practices, because it forces you to do your own work, I guess. Oh, I put the wrong one. I gotta put the 0.21. 0.21030. I'm doing 5 decimals. Whatever, it's working. Number 5. Chance of IRS auditing you for your tax returns with over $25,000 in income is about 2% per year. We're interested in the expected number of audits. There's the key word. Expected number means they're asking you for the average. On average, how many times will you get audited in a 14-year period? Okay. Given the population follows a binomial distribution, find the probability a person is audited more than 3 times. More than 3 times in a 14-year period. Now, I think I was a little bit wrong about. We're interested in the expected number of adults. So they're just looking at, in a 14-year period, how many times are you going to get audited? And what's the probability you would get audited, for my version, more than, it says for me, more than 3. So I got setting up again. I've got 0, 1, 2, 3, 4, 5, dot, 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 all the way to 14 years. They want more than 3, so that does not include 3. They want this. And again, I can find the blue box much easier. So the probability of x being greater than or equal to 4 equals 1 minus the blue box, the probability of x being less than or equal to 3. And that is 1 minus binomial CDF. And then we've got 14 for n. We've got the probability of being audited was 2% for me, and then 3 successes or less. That will do the trick. 1 minus second distribution binomial. 14, comma, 0.02, comma, 3. There we go. So, not likely. I'm going to multiply that. No, shoot, I'm not. That's just going to, scientific notation, right? So I'm going to have to move the decimal over, because I don't think I can type scientific notation in to the MyOpenMath. I'm going to put 0.1234. I'm going to round to 4 decimals. I'm just going to put more decimals and see what it does to me. It didn't like that. Maybe I'll stick with 1. Okay. It wanted that. So that's what scientific notation does, right? It moves it over 4 spots. So in other words, it's not very likely you're going to get audited that many times by the IRS. 6. A machine has a 7% defect rate. If 6 items are chosen randomly, what's the probability at least 1 will have a defective rate? And then it says hint, what's the complement of at least one? So if you've got 0, 1, 2, 3, 4, 5, 6, 7 machines, and you want to know at least one of them being defective, let me let me stay steady with my, that would be here, at least one. My TI-84 doesn't go to the more than side, it goes to the less than side. So this would be what I'm going to count um, and subtract it, okay? So symbolically, it would be the probability of um, x being greater than or equal to 1 equals 1 minus the probability of none. Of x being 0 would be a more mathematical way to say it, okay? Um, so I don't even need the CDF button this time because this right here is an exact. It's exactly 0. It's not a CDF. So 1 minus, 1 minus the binomial PDF of 7 comma, what was the defective rate for mine? I had a 7% defective rate, and I'm subtracting the probability that none of them are defective. And so I have that 389,299. Let's see what happens. It doesn't like my rounding, probably, huh? 3.983. Oh, it says 2 decimals. Wake up, Fog. And that would round to, oh, I just typed it wrong in the first place. 40. What? I think that should work. Oh, Shibuya, I didn't read carefully. It says if 6 items are chosen randomly, I right here did 7 items. There's only 6 items to pick from. N is 6, Fag. So let's see. Hopefully, I don't have to get a new question. I would hate that. 0.35. Oh, saved. All right. Number 7. Delta Airlines flights from Chicago to Dallas are on time 60% of the time. Suppose 8 flights are randomly selected and the number of on-time flights is recorded. So N is 8 and P is 60%. Part A, probability exactly 4 flights are on time. So it's a P because it said exactly. N is 8, probability is 0.60, and I want there to be 4, exactly 4. Round to 4 decimal places, it says 0.2322, bam, bam. Letter B, probability that at most 7 flights are on time. So when it says at most, folks, that means 7 or less, right? So that is a C button, about as easy as a C button can get, because when you put the 7, it includes 7 and goes all the way down to 0. 0.90, how many decimals again? 4 decimals, 9832. Okay. The probability at least 3 flights are on time. So once again, my handy dandy little at least 3 flights being on time. So it goes from 0 up to 8 flights. If you want at least 3 on time, that is this box. That's the probability that you're looking for. And I can find the blue box by doing CDF, right? This would be the CDF button of 8.60 and then 2 right there. And then I subtract that from 1, right? Like I've been doing. Okay. 1 minus, bam, bam. CDF, 8 flights, probability being on time is 60, and 0.9502 if we round it to 4 decimals. Okay, last one. A local county has an unemployment rate of 4.3%. A random sample of 20 employable people are picked at random from the county and are asked if they're employed. Round answers to 4 decimals. Find the probability that exactly 5 are unemployed. All right, I'm getting this down. Sample size is 20. Probability of being unemployed. Be careful to move your decimal over to 0.043. And then exactly 5 is what I'm looking for. So that's not very likely, is it? 0.0012 if you round it. Be careful with yours. It'll be different. B, fewer than 4. Be careful when you, this is a C, right? But when you put the last number, it includes that number. So this is not 4. I want fewer than 4, so that would be 3 or less. Remember, that's how the CDF button works. So that's 99%, 0.9905. Um, Part C says more than 2. So are you guys catching on now? We're going to do 1 minus the CDF button of 20.043. And then more than 2 does not include 2. So I want to subtract off this, right? It's exactly like this, actually, what you can see right here. You know, it goes higher than 8, but more than 2 would be 3 and higher. So I want to find 2, 1, and 0 with the CDF button in this manner and subtract it from 1. And there's my answer. 0.0525 if we round it. Last one. Probability there's at most 4. Um, this is very similar to B, but not quite. At most 4 means you could have 4 people that are unemployed, 4 people or less. I'm just going to go up here, grab this, and back up and make that a 4. So B said fewer than 4 for me. D said at most 4. So that cutoff is always the tricky part. 0.9987 when you round it off. There you go, folks. That's it. Later.